We are in the week 4 problem solving session of the NPTEL course Network Analysis, and week 4 is about mesh and nodal analysis with time varying source. Let me share my screen. Are you able to see my screen?
Yes, sir.
Okay. Okay, today, so hope you have gone through the lecture. So week 4 is about mesh and nodal analysis with AC input or time varying source, basically sine or cosine. So today our title is mesh and nodal analysis with time varying source. So it could be any source, but usually we are talking here about sine wave, so like an AC signal. So previously we have done in the earlier weeks the DC analysis. So that time we were talking about the steady state. So we have calculated the steady state currents, voltages, etc. And a week later to that we have discussed about furthermore aspects. And last week we have discussed about this solution to linear differential equations, maybe first order, second order, or higher order with different type of excitation, say constant or time varying input sine. So we have realized or understood how to solve a circuit if we are given any RLC circuit. First we'll get the differential equation and then how to solve without actually solving. So we got some results, and using that results we have solved few circuits. So that is a normal basic circuit. In this this week we'll discuss about few aspects instead of actually going to solve that time varying thing. Can we do it any much simpler way so that I need not solve the differential equation each and every time? So let us consider one RL circuit. Say I have considered one resistor, and I have one inductor, and there was a switch. And consider input source Vs. You are able to see my screen, right?
Yes, sir.
Okay. If you face any difficulty in understanding, you can stop me at any time. Say at t equals to 0, we are closing this. So now can you tell me what will be the equation, differential equation? So I have given this condition IL of t at t equals to 0 is 0. So we have started the circuit at t equals to 0. Before that, it is in the steady state, so inductor current is 0. Now at t equals to 0, we have closed the switch, so current will flow. Now can you tell me what will be the, how to solve such type of?
R into I1 L di by dt.
Yes. So if we apply KVL, it will be VR plus VL is equals to, say input source is VS. We'll have VS, which is VM sine omega t. And VR is nothing but IL into R plus L is nothing, VL is nothing but L dIL by dt is equals to VM sine omega t. So now I'll write this in the linear differential equation format, so we can directly apply whatever we have studied in the last week. So it will be dIL by dt plus R by L into IL is equals to Vm by L sine omega t. Omega is in radians, say. So now we got this equation. So from here, can we how to solve this? So it is in this format, like say dy by dt plus some constant ay is equals to a sine omega t. It is in this format. So how to solve this? We have discussed in the previous week. So like, yeah, how to proceed? Any ideas? Any suggestions? So first of all, how many solution does y has? We have discussed it has two parts. Y, what y f of t and y n of t. What are y n of t, y f of t? Hello. So let us represent IL as y so that it would be easy to write every time. Anyone? So how to say I have given you one equation, differential equation. So we have discussed that each differential equation with some input has two solutions. One is what solution and the other one is what solution.
Sir, forced response and natural response.
Yes, yeah. Natural response and
Forced response.
yes. So y will have two terms. So we will solve for them individually. So y of t will have natural response say y n of t and forced response say y f of t. So we'll solve for them individually. And what will be y n of t for this equation? So natural response is when input is 0. So you replace RHS by 0. So we'll get something like this dy by dt plus r by l y is equals to 0. So now how can we write it? It will have an exponential term, right? So how can I write y n of t?
Sir, e raised to power minus r by l into t.
T, yes. And also there will be some constant because we are writing a generalized expression. So it will be a into e to the power minus RT by L. Yeah, you are right. So this is my natural response. So what is the value of a? We'll come back. But first we are writing the generalized solution. Then we'll calculate each and every constant by using the initial condition that I have specified. Inductor current at t equals to 0 is 0. So now yf of t is what? Yf of t is the forced response. So now if the forced input is a sign, we have discussed how to solve such problem. So how to solve that? So now we will consider the input. So it will be dy by dt plus r by l into y equal to Vm by L sin omega t. So how to proceed? Anyone? Your voice is breaking. Yeah, anyone? Okay, so when we have discussed,
Sir,
yeah, someone is saying, hello.
sir, we multiply some constant K1.
Yes. Yeah, tell
K1,
me. Well, I'm not able to hear you properly.
sir, K1 into x of t plus
Yes.
K2 into derivative of x of t
Okay.
extra t plus K3 into the double derivative of x of t and like this.
Yes. You are partially right. You are partially you are partially right. Because that is when the input is a say some polynomial, so that the derivative at some point of time will become 0. But if the input is say exponential or sine, if I take derivative of sine, it will become cosine, and cosine it will become sine, and again it will keep on
Uh,
continue. So I will not know where to stop. So in such cases, we have discussed.
for exponential, y of t equal to x of t whole divided by so the characteristic equation.
Sorry.
So y of t equal to exponential function x of t.
Yes.
जो भी सर x of t given divided by characteristic equation.
Yes, you are right. So we'll get that characteristic equation, and then from there we'll get. So as my RHS is having sign, first I will write that into exponential term. So what I'll be considering? Sin omega t. If I write in exponential term, what it will be? E to the power j omega t.
E to the power j omega t minus plus e to the power minus j omega t by j omega.
By 2j, right? Not j omega.
By 2j, sorry, sir, by 2j.
Yes. So now I'll substitute it there. So what I'll be getting? I'll be getting something like this. So I'll be getting dy by dt plus r by l into y is equals to Vm by L into e to the power j omega t minus e to the power minus j omega t by 2j. So we have discussed if there is an exponential term on the RHS side, we are free to assume that our y of t, or to be precise, y f of t, we can assume some k1 into e to the power j omega t plus some k2 into e to the power minus j omega t. So we'll assume this and then we'll back substitute it to get k1 and k2, and we have discussed this last week. So substitute to find k1 comma k2. So yeah, all of you please do the calculation along with me. So if I substitute it, what I'll be getting, you also take a pen and paper and do along with me. So yeah, tell me, can I know k1 into j omega e to the power j omega t minus k2 j omega e to the power j omega t plus r by r k1 by l e to the power j omega t plus r k2 by l e to the power minus j omega t is equals to Vm by L times 2j e to the power j omega t minus Vm by L times 2j into e to the power minus j omega t. So now we'll compare e to the power j omega t and e to the power minus j omega t terms on LHS as well as RHS to get k1 and k2. So here I have two equations, two unknowns. So first I'll compare e to the power j omega t terms. Compare e to the power j omega t coefficients. So if I compare, what I'll be getting? I'll be getting something like this: k1 into r by l plus j omega is equals to Vm by L times 2j. I'll be getting something like this, right? Hello, are you able to follow? Hello. Hello, am I audible? Okay, someone has mentioned yes, sir. Okay. So similarly for e to the power minus j omega t coefficient, I'll get in terms of k2. So I'll be getting something like this. So k2 into r by l minus j omega. So you also check, maybe I'm making some mistakes, so you have to correct me, else we'll be getting a wrong result. So minus Vm by L times 2j. So we have something like this. So from there, we have to calculate k1 as well as k2. So are you able to follow until this point? Are you able to get the same expression? Okay,
Yes,
maybe you
sir.
can. Okay, okay. So first I'll calculate k1 and then I'll calculate k2. So k1 is equals to Vm by L into 2j into L by R plus j omega L. So now I'll multiply by R minus j omega L on the numerator and denominator so that I can eliminate this j term in the denominator. So if I do that, first L and L will get cancelled and I'll be left with Vm by 2j into R minus j omega L by R square plus omega square L square. Do you agree? K1 by K1. I have just multiplied by R minus j omega L on the numerator and denominator so that I'll get j in the numerator. This 2j I have kept it because if it will be like e to the power j omega t minus e to the power minus j omega t by 2j, I need 2j in the denominator. So I have kept the 2j as it is and I have taken the j in the numerator. Okay. So if you face any difficulty, stop me. Don't hesitate to ask any question. Now I'll be calculating for K2. So K2 will be minus Vm by L into 2J into L by R minus J omega L. So for this, I'll multiply by R plus J omega L by R plus J omega L. So now what I'll be getting? I'll be getting something like this. So it will be minus Vm by 2J into R plus J omega L by R square plus omega square L square. Are you able to follow until this point? I have just calculated K1 and K2. So I have assumed this forced input because I know from the last week, whatever we have discussed, that forced input will be in this format. And as the forced input should satisfy the given equation, I have substituted there. And after substituting, I got a expression, a complicated expression. Then I know I can compare e to the power j omega t terms on LHS as well as RHS. From there, I got K1 and K2, and I have written in this format. Now I will go back to my original forced response equation, which is my yf of t is equals to K1 into e to the power j omega t plus K2 into e to the power minus j omega t. So now you substitute these equations, okay? So whatever we have gotten here, you substitute K1, K2. I hope you are following. I'm not going too fast, right? If you want me to slow it down, I'll go slow. If you are fine, we'll go at this pace. We are just trying to solve the equation which we have gotten from this basic RL circuit. So are you following? I'm not hearing anything from you.
Yes, sir.
Okay. So I'll just substitute K1 and K2, and then I'll segregate e to the power j omega t term and e to the power minus j omega t term. So I'll be getting something like this. So y f of t is equals to Vm by 2j. I'll take common, multiplied by R by R square plus omega square L square. I'll take common. Then I'll be left with e to the power j omega t minus e to the power minus j omega t. So this is the first term. And in the second term, I'll have again, I'll take minus Vm by 2j common because there is a minus term here. And again, there is a minus term here. So I'll take minus Vm by 2j into j omega L by R square plus omega square L square common. And as both minus we have taken common, it will be a plus. So it will be e to the power j omega t plus e to the power minus j omega t. So is this clear until this point? I have just segregated this term and that term so that I can write in sine and cosine terms in the way we want. Okay, so now we know that this term is what? So what will be that term? E to the power j omega t minus e to the power minus j omega t by 2j?
Sin omega t.
Yes, sine omega t. R by R square plus omega square L square into sine omega t. Now again minus is there, so I'll put minus. I'll use a different color. So J will get cancelled. And now what will be this term? E to the power j omega t plus e to the power minus j omega t by 2.
Cos omega t.
Cos omega t, yeah. R square plus omega square L square into cos omega t. Cos omega t, yes, you are right. Now I have Vm common and sin omega t, cos omega t. From this, I can see that it is in a particular formula, sin theta like sin A cos B minus cos A sin B. So if we consider A to be like say sin theta 1, sin theta 2. So this I'll consider some cos theta, and this I'll consider sin theta. Okay. So now it is in what format? Sin omega t cos theta minus cos omega t sin theta. So that will become what? Yf of is equals to Vm into sin omega t of
Sin omega t minus theta.
sin omega t minus theta. Yes, you're right. So this is my forced response. Okay, so Vm is sin omega t minus theta, where tan theta is omega L by R, or theta is equals to tan inverse omega L by R. So this is my forced response. So just to summarize, for forced response, we have converted this sign into exponential terms, and then we have written the generalized solution, and we have then back substituted this expression in the given differential equation to solve for k1, k2. We have solved k1, k2, and then we have again substituted in our solution to get the forced response solution. So yf of t is Vm sin omega t minus theta. And I know my natural response is A into e to the power minus RT by L. Okay. So now the overall solution becomes overall solution y of t is equals to A into e to the power minus RT by L plus Vm sin omega t minus theta. But how do I find A? Anyone? How will I find A? So in the natural response, there is still one unknown which I'm yet to find. So how will I be finding that?
By putting the boundary condition given. At t
Yes,
equal to 0, y of 0 is given.
yes. And you have to excuse me. So this we cannot consider cos theta by cos theta to be r by r square plus omega square L square. There will be a square root. So I have missed that square root term. So I will put this square root term here, and I'll put this square root term here, and then I'll take this 1 by square root of r square plus omega L square common. Because if my theta is this, and this is omega L, this is r, then this will be r square plus omega square L square, right? So that part we have missed. So our sin theta is omega L by square root of r square plus omega L square, and cos theta is r by square root of r square plus omega square L square. So there will be another root which I have written outside. So that omega square L square will be coming here. This by square root of r square plus omega square L square. Is this part clear, which we have missed? So r by r square plus omega square L square cannot be considered. If it is considered cos theta, then this will not be sin theta because there will be one square root. So I have written it in two, like a square root of a whole square. I have written a as root a into root a, and the other root I have kept it outside as a constant. So my solution will be Vm by square root of r square plus omega square L square sin omega t minus theta. Yeah, someone has answered. We'll put the boundary condition, which we have given IL at t equals to 0 is equals to 0. So we'll substitute t equals to 0. Then we'll get 0 is equals to A plus Vm. Again, there will be this by square root of r square plus omega square L square. So we'll get Vm by square root of r square plus omega square L square into t equals to 0. So it will be sine minus theta, right? Right? Or is this fine?
Yes, sir.
Yes. So now what will be the value of A? What is the value of A? Can you calculate?
Vm sin theta divided by square root of r square plus omega square L square.
Yes. So minus minus will become plus. So it will be Vm sin theta by square root of r square plus omega square L square. So now I will back substitute it to get the overall solution. And I will replace by the current. So the inductor current, therefore the inductor current IL of t as a function of t can be written as IL of t is equals to Vm sin theta by square root of r square plus omega square L square e to the power minus RT by L plus Vm by square root of r square plus omega square L square into sine of omega t minus theta. So this is my solution. So it has one exponential term and one sine term. So exponential term is coming because of the natural response and the other term is coming because of the forced input. So this part is coming because of the natural response. And this part is because of the forced input. Okay. So at t equals to 0, we have considered this circuit to be closed. So RL will be, this will be closed and we have excited with Vm sin omega t. Now what happens is we want to check the steady state inductor current or any voltage at steady state means after infinite amount of time or after it has settled. So if we consider a certain amount of time, this exponential term will decay to 0. So at steady state, exponential term will be decaying to 0. So at steady state, exponential term will decay to 0. So now we'll be left with which term? Hello. So if I consider at steady state, what will be the expression? Which term will have in IL of t? Oh, sorry, your voice is breaking. Yeah, someone has mentioned forced response. Oh, sorry,
Root
your
over of r
voice is
square plus
breaking.
omega square sin omega t minus theta.
Yes. So IL of t at steady state, SS I am representing as steady state is equal to Vm by square root of r square plus omega square L square sine omega t minus theta. So this will be my inductor current at steady state. So for sine input, sine omega t input with a like voltage source magnitude, peak magnitude Vm, we are getting this inductor current. So my just a minute. So my V of t is Vm sin omega t, and my inductor current is also sin omega t, but delayed by theta. So if any such circuit is given and we are trying to solve it, we need to solve in this way where we'll get this differential equation and solve. But this is just a very simple circuit RL. What if I add C? Then it will become second order. Then everything will become quite complicated. So in such way, in such scenarios, how to solve those kind of equations. So that's why there is this method that is introduced, which is phasor. So we'll consider the phasor of R, L as well as C, and we consider it in imaginary plane, real and imaginary plane, and using that we'll solve for the circuit. So this is our solution. Whereas our V of t is Vm sin omega t. So instead of solving in this entire way, there is a shortcut where we'll consider this complex impedance, current, everything, and just solve it in a way we solve any DC mesh analysis or nodal analysis. Say the circuit is closed and the circuit is something like this. So we have Vm sin omega t. So the plane is something like this. So it has real plane and imaginary plane, and we'll consider magnitude with theta. So if I consider r angle theta, so this is my 0 or real plane, and this is my imaginary plane. So this is 0 degrees and this is 90 degrees. So if I have r angle theta, or e to the power j theta, we'll represent it as r angle theta. So it is r cos theta plus j r sin theta. So it is r cos theta here and r sin theta here. So this is the phasor representation. So now the net summation will be like this. So this is my r at an angle theta. So when I say r angle theta, it is having a magnitude r at an angle theta with the x-axis being real and y-axis being imaginary. So now we have Vm sin omega t. So any input of the form Vm sin omega t plus 0 degrees. So omega t, apart from the omega t, we'll consider its phase to be 0 and we'll represent it as Vm angle 0. And this is just a representation, a complex representation, so that we can solve this circuit easily. And in this format, for the case of L, we'll consider j omega L as the reactance of the omega L. So for resistance, it will be just the resistance R. For inductance, it will be j omega L. So this is the inductive reactance. And for capacitance, it will be 1 by j omega C. So this is the inductive reactance. And then this is the capacitive reactance. Okay. So now I will replace the circuit with the conventions that we have selected. Now the circuit will become something like this. Vm angle 0, and this is R, and this is j omega. Now I have converted everything into phasor, j omega, not C. Now I'll have to calculate for I phasor, say I bar. So now I is given by, so or I angle theta, you said, I angle theta, magnitude having I and angle having theta, or theta we have used for other things, so we'll not use theta. We'll use I bar only. So I bar is just voltage by impedance, right? Voltage is what? Vm angle 0. And what is the impedance? Hello.
R plus j omega L.
Yes, R plus j omega L. So now this is a complex term. So it has a magnitude as well as phase. So we have studied in complex numbers. Say if I have R plus j omega L, I can write in terms of some R angle theta, where my R is given by the magnitude of this. So what is the magnitude of this? Square root of R square plus omega square L square. And theta is nothing but tan inverse of imaginary coefficient by real coefficient. So you may ask me, how did you get this? So whatever representation we have written R angle theta, we know that R angle theta is e to the power j theta. So R angle theta is e to the power j theta, which means cos theta r into e to the power j theta. So r cos theta. So I think we have missed one r term here. So r angle theta means r into e to the power j theta. So I have missed this r. So r cos theta plus j r sin theta. So if I compare these two, we get r cos theta is equal to r sin theta is equals to omega l. So from this I will get square root of r square cos square theta plus r square sin square theta is equal to r is equals to square root of r square plus omega square l square. So that's how I got this term. Now for calculating theta, I will divide sin theta by cos theta. So I will get tan theta is equals to omega L by R. That implies theta is equal to tan inverse omega L by R. So that's how I got this term. Okay. Okay, so now is it clear until this point? So we have solved for tan theta, and then I'll again go back. So I'll write this denominator in this format: square root of r square plus omega square L square into tan inverse omega L by R. So my I is nothing but Vm angle 0 degrees by square root of r square plus omega square L square into tan inverse omega L by R. And one more thing you need to remember. So in this representation, say we have R1 angle theta 1 by R2 angle theta 2. Then I can write it as R1 by R2 angle theta 1 minus theta 2. So theta will be subtracted if they are in the division, and magnitude will be just like a normal division. And say we have R1 angle theta 1 into R2 angle theta 2. Then we have R1 R2 angle theta 1 plus theta 2. So these things you kindly remember. You can even solve it using by hand and check whether these are coming satisfying or not. But yeah, just so that you can remember. From this I will get I is equals to Vm by square root of r square plus omega square L square. Angle 0 minus this one will be minus tan inverse omega L by R. Okay. So again, I'll write that here, whatever I am getting. So I of t, I am getting Vm by square root of r square plus omega square L square angle minus tan inverse omega L by R. And V of t, I have Vm sine omega t, or I can also write as Vm angle 0. So if I am representing r angle 0 degrees as r sine omega t, then my r angle minus theta will be r sine omega t minus theta. So this is just a representation. So we have represented r sine omega t as r angle 0. So r angle minus theta will be r sine omega t minus theta. So because we are considering only the angle. So now my I of t is Vm by square root of r square plus omega square L square angle minus tan inverse omega L by R. So if I have to write this in time domain, like using sine, what will be the expression? Can someone tell me? Hello, can you hear me? So we have started with this representation, this notion of representing V sine omega t as some r angle 0 or Vm angle 0. So when there is omega t plus some angle 0, we have represented it as Vm angle 0. But if I have r angle minus theta, we are discussing that it can be written as r sine omega t minus theta, because minus theta is there. So the in sine representation, it will be sine omega t minus theta. So in such cases, my I of t is as shown here, Vm by square root of r square plus omega square L square, angle minus tan inverse omega L by R. So if I write this in sine term, so what will be my expression? Can someone tell me? Using these two, we are just mapping between two notations. One is the time domain, one is the phasor domain. Hello, anyone? Can you hear me? Hello. Yeah, someone has mentioned in the chat. Yes, sir. Okay. So, okay, if you are facing issue, I'll just repeat what I'm trying to say. We have defined a notion, phasor notion, so that we can simply solve this circuit without solving the differential equation. So in that notion, we have uh, denoted our Vm sin omega t as Vm angle 0. So if I have Vm angle minus theta, it will be Vm sin omega t minus theta. So I'm considering the magnitude Vm as Vm and the angle is omega t plus whatever angle is there. So omega t I am not considering in my calculations and I'm proceeding with that. So whenever I convert that back into time domain, at that time I'll be considering. So I have calculated this in the phasor domain. So if I use this logic and write my I of t, I will get something like this. My I of t will be, again, this is not I of t, sorry. So I cannot write t because this is a phasor. So I bar phasor. My I of t will be, so now this will be I of t. I of t will be, now I can write in sine terms. So Vm by magnitude is square root of r square plus omega square L square into sine of omega t plus this angle. So omega t minus tan inverse omega L by R. So now what have we concluded or what have we understood? What we have understood is if there is such circuit as series RLC or RL or RC, if such circuit exists, then instead of solving it using the differential equations and calculating the very complicated expression and doing lengthy calculations, instead we can use this phasor notation where we'll write this in r angle theta, where we have studied r angle theta is r into e to the power j theta or r cos theta plus j r sin theta. And then using this notation, we have solved. And in simpler steps or lesser steps, we have realized that it can be solved. So if you see, or if you remember, we got the same expression, isn't it? Did we not get the same expression? I of t? Previously, we have solved using differential equation method, the
Yes, sir.
conventional
It's the same equation, sir.
Yes, so we got the same
Same
equation.
equation, sir.
Yes, so it's for now we are actually solving the AC analysis. So if the input is AC and we are solving for currents or voltages at a steady state, then we need not go by the classical method where we solve the differential equation. Instead, we can use this simpler method and then we'll get the same expression. So just to show you, so this is my expression where I have considered this phasor and I have solved. In the previous case also at steady state, I got the same expression, but here I have solved in lesser number of steps, whereas here I had to solve 2 pages full calculations to arrive at the same expression. So it is just solving the circuit in a much faster way. So just to check your understanding, I will consider another quick problem. Say, now I am considering RL circuit or RC circuit. I am considering V sin omega t and this to be R, this to be C. So how will I proceed if I ask IC or I phasor? I'm asking I phasor. So it is just I have replaced L with C. So how will I proceed?
So first, find the Z,
Yes.
then I equal to Vm by Z.
Yes. Can you tell me what will be the expression of Z?
Z equal to R minus Jxc.
Yes. R minus Jxc. You are right. And
Jxc.
Xc is 1 by omega c. So R minus J by omega c, right?
Yes, sir.
Yes. Now, if I want to find mod Z is square root of R square plus 1 by omega square c square. And the angle of Z is minus tan inverse.
Tan inverse Xc by R.
Yes. So 1 by
Omega
c.
c.
Yes.
1 by omega c R.
Yes, you are right. So I have got Z. Now for calculating the phasor, I will use whatever you have told. So how to calculate phasor? I.
Whether I equal to V by Z. V in polar form, V angle 0 by Z angle theta.
Yes. So we will get I phasor is V phasor, which is V angle 0 by our Z. Z I have represented as mod Z. So mod of R square plus 1 by omega square c square into angle Z. So angle minus tan inverse 1 by omega CR. So now I will just use whatever we have told. R1 angle theta 1 by R2 angle theta 2 is R1 by R2 angle theta 1 minus theta 2. So using that, I will get my I phasor is V by square root of R square plus 1 by omega square c square angle plus. So tan inverse 1 by omega c R. So this is my R angle theta form. Now if I have to, or if I want to convert this into my time domain, so it will be, can anyone tell me what it will be in time domain? It will be sine omega t plus theta, where theta is tan inverse.
F equal to Vm by R.
Okay, so I have got this type of expression. Yes, so now I can see that I can simplify complicated circuit within few steps. So now let us again go back to our this circuit, RL circuit. So we'll discuss another important aspect, which is the complex power. So what is complex power and why we are saying it is complex power? So this is our last concept before we dive into problem solving session. So just I'm revising theory what Sir has told, so that if you have any doubts you can ask or you can better understand. So with this, after this we'll go into problems. So again I'm considering the same RL circuit with the same Vm sin omega t and R, L, and this is t equals to 0. So we know that V of t, or the input. So input is V of t and this is I of t. So V of t is Vm sin omega t and I of t is what? Vm by square root of R square plus omega square L square sin
Vm by R
omega
square
t.
root of R square plus 1 by omega square omega t plus tan inverse 1 by omega c R.
Yes. No, this is RL, so it is omega L by R. I am considering this as Im. So I will get Im sin omega t minus theta. So I now will calculate my power. My power P of t is V of t times I of t. So V of t is nothing but Vn sin omega t
Sir, in the sir, okay, sir, okay, sir.
Okay, got it right. Vm sin omega t into
Yes, sir.
Im sin omega t cos theta minus cos omega t sin theta. Now we'll segregate cos theta terms one side and sin theta terms on the other side. So we'll get P of t is equal to Vm Im sin square omega t cos theta minus Vm Im sin omega t cos omega t sin theta. Now I'll simplify omega t terms. So I'll be getting B of t is Vm Im by 2 cos theta into 1 minus cos 2 omega t minus Vm Im by 2 into sin theta into sin 2 omega t, isn't it? Is this hello?
Yes, sir.
Yes. So we know that sine term and cosine term will vary from 0 to 2, sorry, minus 1 to 1. So we know that cos theta minus 1 less than or equal to 1. So 1 minus cos theta will lie from 0 to 2, right? Right, isn't it? If we know that cos theta is minus 1 to 1, similarly sin theta is minus 1 to 1. So 1 minus cos theta will lie from 0 to 2, right?
Yes, sir.
Yeah. So we have two terms here, and we know that this term is always greater than or equal to 0 because it lies between 0 to 2. And this term could be greater than 0, could be less than 0 because it lies between minus 1 to 1. So our power term, if you see our power term, so one term is always positive and the other term is maybe positive, maybe negative. So this part is real power and this part is imaginary power, because real power cannot be negative. So the power that source is supplying will always be positive. And these are energy storing elements, right? LNC. So they can store power and they can give it back to the source itself. So these are imaginary power, and this is the this is what? This is the real power, and this is the imaginary power. So this is real power, and this is the imaginary power. So if you consider real power, so the representation is, so what is the representation for R? Real power R, right? Or what is the representation? Complex power, real power, imaginary power.
P.
P, right? R is for
P,
resistance.
P.
So this is P and this is Q. So our real power P is Vm Im by 2 cos theta, where Vm and Im are peak. So I'll write Vm by 2, Im by 2 cos theta. So it will be Vrms, Irms cos theta. And my imaginary power Q will become Vm Im by 2 sin theta, which is actually Vm by root 2 Im by root 2 sin theta. So it will be Vrms Irms sin theta. So the representation for complex power is S is equals to P plus JQ,
J cube.
where S is the complex power and P is the active power and Q is the reactive power. So P is active power and Q is reactive power. Okay, and the units of S is what? Volt ampere. This is watt, and this is volt ampere reactive. Just the representation, but all are power. So if someone gives X VAR or 5 VAR, it means they have given Q. And yes. So if S can be written as mod S theta, then power factor is defined as cos theta. PF means power factor. So these are some definitions that I'm quickly going through. Okay, so we have started with the power, and we have considered V of t into I of t, and from there we came to know that one term is always positive and the other term is positive or negative. So from there we have defined real power and imaginary power, and from there complex power is defined. So S is equals to P plus JQ, or S can also be written as VRMS into IRMS star. Star means the conjugate. So if you have voltage and current, the complex power can be obtained as VRMS into IRMS star. So this sir has already taught, but I'm just quickly revising. One main thing is you have to remember the average of this first term is Vm Im by 2 cos theta. The average of the second term is 0, but Vm Im by 2 is by 2 into sin theta is the peak value. What I mean to say is here Vm Im by 2 cos theta is the average value of this, because the peak value will be 2 times, right? Cos theta 0 less than or equal to 1 minus cos 2 omega t less than or equal to c. So here P is the, say this I'm calling it as first term, and this I'm calling it as the second term. So this P is the average value of first term. So if you take the average value of 1 minus cos 2 omega t, you will get 1. So the average of this value is P. Whereas in the case of Q, average of sin 2 omega t is 0 because it is oscillating around 0. So we are defining this term Q, which is the peak value of the second term. So it is not the average value is 0. So this is the peak value of second term. So that's how we are defining and we are proceeding. So you have to be careful with this. So when we say Q, it is not the average imaginary power because it is 0. We have defined the peak value of that to be our Q, and then we got this S equal to P plus JQ, and S can also be written as VRMS, IRMS star. So until this point, is this clear? If you have any doubts, you can ask before we go further into problem
No,
solution.
sir, no, sir.
Okay. So just
No,
so
sir.
if someone has missed some aspects, I'll quickly summarize what we have discussed today. So the week 4 is about mesh and nodal analysis with time varying source, basically AC excitation. So we have started with a basic series RL circuit, which is started at t equal to 0. So the current is 0 and the input is Vm sin omega t. So first we have proceeded with the classical approach where we write the differential equation and solve it. So we have written the KVL and we got the differential equation. We solved for natural response by keeping input to be 0, which is an exponentially decaying term, followed by the forced response, which we have obtained by converting this sign into exponential term. And we have considered a generalized solution for this expression. And by back substituting this generalized force response into the given or the obtained differential equation, we got this complicated expression, and solving for the coefficients of e to the power j omega t and e to the power minus j omega t. By comparing them, we have solved k1 k2, and I have substituted k1 k2 back in the solution. Then I got this expression. So now the overall solution becomes like this, and to solve for A, we have considered the boundary condition and or the initial condition, and I got A. So this is my overall solution, but I'm only interested in the steady state when this exponential term has fully decayed out. So at steady state, this is my solution for this input. But this process is lengthy, so there is also another method which is proposed by scientists. where we consider the phasor. So there is this real imaginary axis. So on if there is some r into e to the power j theta, which can also be written in r angle theta phasor. So it has r cos theta on the real axis, j into r sin theta on the imaginary axis. So this is this real, and this is the imaginary. So this is that j axis, and this is the real part. And so it has angle r at an angle theta. So using this convention, we have represented Vm sin omega t as V angle 0. And for the impedance, we have to consider the complex impedance. So for L, it will be j omega L, and C, it will be 1 by j omega. So after substituting them and solving for current just by applying V by impedance. So this is now impedance. It is no more resistance. So this part is called impedance because it's a complex term, just a mathematical representation. Then we have solved for current, and we uh, solved this phasor, and then the final phasor what we got is the same as what we got in the classical approach. So it is just the same thing, but much shorter way. Similarly, we have taken an example of RC, and again we have solved for I of t, and it is just a few steps. Whereas if you consider the classical approach, it will take time, and it's also lengthy. Similarly, complex power is having real power as well as imaginary power. So we have multiplied V of t, I of t. Then there are two terms. One is the real power, one is the imaginary power. And real power P is nothing but the average value of the first term, and the imaginary power Q is nothing but the peak value of the second term. And we have represented it as this, and complex power is defined as S equal to P plus JQ, where P is VRMS IRMS cos theta, and Q is VRMS IRMS sin theta. So it can also be written as VRMS into IRMS angle theta, or it can also be written as VRMS IRMS star. Actually, I should not write RMS, it should be V phasor. So V phasor into I star phasor. So it is V phasor into I phasor star. So V into I phasor star, and we have to consider only the RMS values because we are only interested in the RMS values. So this is the summary of what we have discussed today. So now let us quickly go into the problem solving session. So I hope it is clear until this point. If you have any doubts, you may ask.
Yes, sir. Yes, sir.
Okay.
No, sir.
Okay. So yeah, they have given this type of question, and they're asking for IC, IR, IL. Okay. Let us take a snip of this question. Okay, so so this is a comprehensive question which has 8 subparts. So this is our problem 1. Okay, so how to proceed with this? They have given R, they have given C, they have given L, and they have given input angle 45 degrees. And there is this another R. So how shall I proceed? And they have given input to be 50 RMS. So when we say V angle theta, this theta can be RMS or it can be peak also. It is up to one's representation, but it would be good if we keep RMS, because whatever power calculation we do, it is in RMS value. So, but you have to take a note of that. If they have given peak, then you have to convert it to RMS and solve, or you keep everything in peak, and for calculating power, you have to consider only RMS value. So that notation you should be very careful. So if such questions are given, first I'll convert everything into my phasor domain. So we know that R will be same as R, and L will be j omega L, and C will be 1 by j omega C. And they have given omega to be 200 radians per second. So now can someone quickly calculate and tell me what is j omega L and 1 by j omega C? So I'll redraw the circuit as this. So my input is given as 50 angle 45 degrees. This resistance is 70 ohm and this resistance is given as 30 ohm. So now what will be my L and what will be my C? Can anyone calculate? L will be J into 200 into 40. So it will be what? 40 milli into 200. So 8000 into 10 to the power minus 3. So it will be J8, right? X. Isn't it? Hello? Hello?
Yes, sir.
And what will be C? C will be 1 by j omega into C. So 1 by 200 into 0.628. 625.
8 into 10 raised to power 8 into 10 raised to power minus 3.
So what calculate and tell me 1 by j omega C. What will be 1 by j omega C? And one more thing, if you have scientific calculator, you can use the complex domain and you can solve in the calculator itself. I don't have the calculator with me currently, so I cannot show. Okay, so anyone? I have calculated and it is coming to be minus j8. So kindly check and let me know if it is coming minus j8. Is this fine? Hello.
Sir, 8.
Minus,
Yes,
right?
sir.
Minus j.
Yes,
Minus j
sir.
will be there. 1 by j is minus j. So now I'll give you one small task. So if you have two impedances in parallel, what will be the net impedance? X1, X2 by X1 plus X2, right?
Yes, sir.
So now can you calculate for this L and C? So we have X1 to be J8 and X2 to be minus J8. So if I want to calculate the net impedance so that I can represent using a single impedance block and L and C are in parallel. So what will be my net impedance X1, X2 by X1 plus X2? Can someone calculate and tell me quickly?
Infinity.
Infinity. So
Infinity.
what does that mean? If I'm combining
Open
these
circuit.
open circuit, yeah, right, very good. So if I combine L and C, it means as if they are not drawing any current. So the impedance is coming infinite. So it means I'll simply remove both of them and my circuit will still behave the same. So that's what it means. Now I'll consider the rest of the circuit. So this is 50 angle 45 degrees. This is 70 ohm. This is 30 ohm. So now can you calculate the current and tell me what will be the I phasor?
0.5 m.
Okay, but angle?
Yes, sir, minus 45 degree.
Or plus
45.
Plus 40.
plus
45.
45, right? So
Plus
my
45.
yes, my I bar is 50 by 100. So 0.5 angle 45 degrees ampere. So now I got I. So at least I got some value in the circuit. I'll quickly go back and see. They are asking what is IC angle theta C, IL angle theta L, IR angle theta R. Okay. Forget about IR theta R, IL theta L. We'll go to IC theta C. So now we have calculated I, right? So I know this I. I know this I. So can I calculate V, this voltage V? What will be that voltage V? V phasor?
50
I
upon
into-
angle 45 minus I into 17.
Sorry. So this V, I mean to say this V. Can you please repeat? I could not follow. Hello.
0.5 into 30.
Yes, 0.5 into 30.
30.
So my V phasor is 0.5 angle 45 degrees into 30 ohm. So my V phasor is 30 into 0.5 is how much? 15, right? 15 angle 45 degrees volt. So now I got the voltage across resistor, which is also the voltage across inductor, which is also the voltage across the capacitor. Now they are asking current through the capacitor. So how will I find current passing through the capacitor? I say angle theta c. How will I find? Hello. I know the voltage.
Sir, V by XL.
Yes, V by XC. So now I'm solving for capacitor. So capacitor current IC angle theta C is nothing but the voltage 15 angle 45 degrees by the impedance minus J into 8. So can you quickly calculate and tell me, if you have calculator, what will be this value? I also have calculator, so if you make a mistake, I will know, because currently I don't have calculator. So you're using calculators, right, for solving this type of equations? Hello. Okay. Yeah, quickly tell me. First, yeah, you just solve it.
0 minus J, angle is magnitude is 8.
8. It is 15 angle
Magnitude is
40.
8.
1.875 at an angle 135.
Yes, 1.875 at an angle 135. Because 15 by 8 will be the magnitude. So IC angle theta C is equal to 1.875, right? 1.875 angle 135 degrees ampere. Okay. So this is my IC theta C. So if you make a mistake, kindly check your calculation. This is what you will be getting. So I have calculated IC theta C. So I will go back and see whether I'm getting the correct answer or not. So IC theta C. So IC is 1.875. It is lying in the range, and theta C is 135 degrees. So again, sometimes you have to check whether they are asking angle in 0 to 360 range or minus 180 to 180. Say angle we got 240 degrees. So 240 degrees is equivalent to what voltage? I mean, what angle if it has to lie in this range? 240. For example, say theta is I'm getting 240 and I have to convert it in a way that it lies between minus 180 to 180 degrees.
120 minus
Yes,
120.
minus 120. So that part you should be very careful. You have to see in what way they are asking. So if I draw the phasor, 240 is something in this. Say 240, right? 180 plus 60 degrees. And this is 180 degrees. So either I will go in the anti-clockwise 180 degrees plus 60, 240, or I'll go in this minus 120 degrees. So sometimes they ask in this region minus 180 to plus 180. So you have to check in what range they are asking. Probably you got the right answer, but if you do not convert it into the proper value, then it will detect as wrong answer. So you have to be very careful with that. Okay, so we have calculated IC angle theta C. Now IL angle theta L. So how will I calculate IL angle theta L?
V by XL.
Yes, V by XL. So can you quickly calculate?
1.875 at an angle 45, minus 40.
Okay.
Minus 48.
Yes. IL angle theta L is 15 angle 45 degrees by J into 8. So 1 IL angle theta L is 1.875 angle minus 45 degrees ampere. Kindly check. You'll be getting something similar. If anyone is having any query, you may ask. So we know the voltage across the inductor, which is again 15 angle 45. Again, there is less than a minute. So if this meeting can kindly quickly join back. So we know the voltage across the inductor, and we know the XL. So current is nothing but V by XL. So we have calculated V as 15 angle 45 XL is J into 8. So we have divided it and converted it into phasor angle. And this is what we are getting. If this meeting ends, quickly join back. So now we'll go to resistor. Okay. So if we go to resistor, what will be the value of IR theta? Has anyone calculated?
0.5
0.5
angle
at
45 degree.
angle 45.
Okay. Okay. You are right. So 15.
Yes, sir.
Okay. So now we also got IR angle theta R is 0.5 angle 45 degrees ampere. So we'll quickly go back and see whether IL angle theta L, IR angle theta R, whether they are okay or not. So IL angle theta L. So we'll quickly go back. IL is how much? 1.8 sulfur. It is within the range. And theta L minus 45. It is also within the range. IR is 0.5 within the range. And theta R is also 45 degrees within the range. So before we go into question 7 and 8, I have one point. Sorry.
What about theta C? How we write the answer? Theta C.
Theta C is 135 degrees. So theta C.
Sir, why we write in the sir,
Sorry.
if the range is greater than 180 degree,
Yes. So
so how it would, please tell one
yes.
second.
So if the theta is greater than 180 degrees, say here I am considering 240 degrees. So 240 degrees in the anti-clockwise direction is equivalent to minus 120 degrees in the clockwise direction. Say I have angle 240 degrees. In order to convert, I will subtract minus 360, which is minus
Yes, sir.
120 degrees. Say I got an angle minus 220 degrees. So now for this, what do I need to do? I will add
140 degree.
140 degrees. So either you can subtract 360
Minus
or you can add
140
360
degree.
and the value should remain same. So you have to check
Sir,
in the question.
when we are going in, sir, when we are going in, we are considering
Sorry, your voice is breaking. Hello.
Sir, when we are going in anti-clockwise direction,
Yes.
sir, when we are going with in anti-clockwise direction, we take negative sign for the angle.
No, in the anti-clockwise direction, we take positive, and in
And
the
in
clockwise
clockwise,
direction,
we take the positive sign.
yes.
We take the negative. Anti-clockwise, we take the positive. Yes.
Yes. Okay, so before we proceed further, I have one question for all of you. So here I have calculated current to 70 ohm, which I got as 0.5 angle 45 degrees. And IR I have calculated 0.5 angle 45 degrees. So I can understand that whatever current that is flowing through 70, it is completely flowing through this 30 ohm. But current is also flowing in these two, right? So how can current that is flowing through 70 will fully flow in 30 ohm? Right. So I mean to say, let me use a different color. Say this current is I1. Okay. This current is I2. This current is I2. This current is I3. This current is I4. So my I1 is equal to I2 plus I3 plus I4, right? According to KCL. Do you agree?
Yes, sir.
But I am
Yes, sir.
getting I1 is equal to I2. So is this right or wrong, or what are your thoughts on this?
The net reactance is infinite. The
Yes.
circuit is based on open circuit.
Yes,
So all
you
the
are.
current flowing through the 30 ohm resistance.
Yes, but yeah, you are absolutely right. But so in such cases, is this not being followed or what? So like irrespective of the impedance, this needs to be happening, right? I1 equal to I2 plus I3 plus I4. But why it is not happening, or is it happening? You are right that it is infinite, so I1 is equal to I2, but KCL should be satisfied. So is the KCL violated here, or still the KCL is satisfied? Any thoughts?
Sir, also across the sir, also across the 30 ohm resistor, the voltage is also V.
Yes,
The three elements are connected in parallel.
yes.
So voltage is same. So I2 is 50 angle 45 by
30, 15 by 30.
30.
Like my query is I3 and I4 summation. What happened to that summation? I3 plus I4.
Summation is 0, sir.
Yes, you are right. So if
Summation is
you
0.
see these two, IC angle theta is 15 angle 45 by minus 8J. This is 15 angle 45 by J8. So what happened is, say my IL angle theta L plus IC angle theta C is equal to 0. So they are taking power, but their power is getting cancelled. So it is like one is taking and one is giving, so that the net is as if they are not taking any current. Because they are not taking any current, we got the impedance to be infinite. As if even if you remove those two, the circuit current, everything will remain as it is, because whatever current L is taking, C is also providing. So from this I will get I2 plus I3 is equal to 0. So the summation of I2 or I3 I4, summation of I3 I4, sorry. So this will be I3 I4 by summation of I3 I4 is 0. So still KCL is happening. So KCL is not violated, but the summation of those two currents is 0. So the entire current is flowing through the resistor, and current is flowing through L and C, but their summation is 0. It is not that 0 current is flowing through them. So that is not correct. The current is flowing, but the summation of the current flowing through L and C is 0. So the current flowing in L is negative of the current that is flowing in C. So that is why the entire current is flowing through this. Okay, so that part is very important to understand. So we'll quickly go back here. They are asking active power supplied by the source and reactive power supplied by the source. So how will I get active power? So active power is P, reactive power is Q. How will I get P and how will I get Q?
Sir, source voltage into source current into cos theta.
Yes. So
Source voltage.
VRMS, IRMS, cos theta. So what is VRMS? What is IRMS? Source again will go here.
VRMS is
VRMS is 50.
Okay.
50.
IRMS
0.5.
and theta.
And cos theta is cos 45 degree.
Is it correct? Anyone? So when we say theta, it is the angle difference between V and I. So theta is not angle of V. Theta is neither the angle of I nor the angle of V. When we say cos theta, theta is the angle difference between V and I. So what is the angle difference between V and I here?
0.
45 degree.
0. So cos theta is 0. Okay. First, let us calculate. Then we'll again come back to a different way of looking at this problem. So P is input is 50, right? IRMS is 0.5. So how much is my P?
25 X.
25. Okay. And similarly, can someone calculate Q? What will be my Q?
Zero, sir.
0. Yes, you are right. So Q will be 0. So why there is only active power and why not any reactive power? That is the question. So any idea why active power is?
Because I3 plus I4 is 0.
Yes, you are right. So we have seen that I3 plus I4 is 0. So as if I calculate the net impedance, it is open circuit. So now this is my net circuit, and in the net circuit I have only resistor. So when there is resistor, there will be only active power. and there is no reactive power. So for that reason, again, cos theta is 1. So here, what is my power factor? Power factor
1.
is cos theta, which is 1. So when we say power factor is 1, which means the circuit is resistive. So it has only resistor, or as if the net impedance is only resistive. Here there is inductor as well as capacitor, but the net impedance seen by the source is 70 plus 30, because the net impedance of this is infinite, as if it is open. So the overall circuit acts as if it is only resistive. So that's why the current drawn is in phase with the voltage. So here if you see 45 degrees, 45 degrees. So theta is 0. That's why power factor is 1. Is this clear, the first problem?
Yes, sir.
So now let us this. So which one you want to solve, this one or this one? We'll have time to only solve one. So whichever question gets more votes, we'll go with that question. So
This problem.
this
14
problem or
mm.
this problem? Others?
14 mm.
This one?
Yes, sir. Yes, sir.
Okay, so this is
Yes,
problem
sir.
1, problem 2. So everyone wants to solve problem 1 then. Okay. So this is our problem 2. It's not that I don't want to solve, but we have less time. So that's why I can only afford to solve one problem. That's why I have asked you which problem you want. But I can give an idea of how to solve the other problem, but I will not get time to solve. So in this problem, they have given L, they have given R, they have given C, and they're asking the capacitor voltage VC can be expressed as this. So now calculate A, calculate B, and they have given one voltage source here, one current source here. So how shall we proceed? Like, what are your initial thoughts? Say this problem has come, two sources are there, and they're asking. So what is your initial thought? Like, how shall we proceed?
By applying the nodal,
Okay. Others, any idea? You give your ideas, then I'll say how to proceed and why to proceed. It's not that this is the only way. There are a number of ways to solve problem, but which would be the optimal way or less time consuming way, we'll proceed with that way. Okay. Anyone, if you have any ideas, like how shall we proceed? There are two sources, so okay. So when there are two sources, we can apply superposition, right? So we'll solve the circuit individually rather than having two sources, which will be quite complicated. We'll solve them individually. Do you agree? Can we do that?
Yes, sir.
Yes. So we'll apply superposition. Say this is my source 1, and this is my source 2. So my source 1, I'll consider first, and source 2 will be open or short?
Open.
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 Open. So always remember, voltage source will be short and current source will be open. So this is very important, else your calculation will be wrong. So first I will consider source 1. Then I will redraw the circuit. So if I consider source 1, this will be open. There is no point of this resistor, right? So this entire this part will be open. So 14, 4 milli. Okay. I will draw the circuit. Here there is the resistor and this is open. And we have the source. So it is 220 sine 300t. And this is how much? 14 millihenry and 4 millifarad. So now we'll transform this into our phasor. What is the omega? Omega is 300 radians per second, right? Okay, so now I'll convert this into the way I want, the phasor way. Instead of solving the lengthy way, we'll convert this into our phasor way. R, you leave it as R. So can someone tell me the impedance? What is j omega L and what is 1 by j omega C? Quickly.
4.2, J
Okay.
4.2, XL.
XL is 4.2, J 4.2, yeah, you're right. And C? Anyone?
Minus 3.833.
Okay. I will keep it as 5 by 6, which is also 5 by 6, right?
Yes, sir.
Okay, so I'll keep it as it is. So they are asking the question, what is VC? So can you tell me what is VC here? What is VC? Minus J 5 by 6 by J 4.2 minus J 5 by 6, 20 angle 0 degrees, right? Do you agree?
Yes, sir.
Okay, can you simplify and tell me what we are getting? I don't have the calculator, so I cannot calculate. So previously I have calculated, so I'm checking your answers from there. So that if you make any mistakes, I'll find out. So as this VC is because of source 1, I'll call it VC1, and for source 2, I'll call VC2. So just quickly tell me what is the VC in R angle theta form. So I want it as R angle theta form. So quickly calculate and see what value you are getting. Okay, anyone?
4.95.
9.5 or
At an angle
4.9?
4.95.
Okay. I was getting 4.9. Okay, we'll see. I'm not sure about that 5 point. Angle 180
4.95.
degrees. 180 degrees. How much did you get?
0 degree 0.
Is it? I
180
feel
degrees,
180
sir.
degrees. So how did I know? Because in the denominator, it is some j positive quantity, right? J into some positive quantity x. So j will get cancelled. So it will be minus angle 0 degrees. So it is 180 degrees. So you kindly check. It will be 4.95 angle 180 degrees. Others, you please check whether you are getting the same answer or not, because everyone should be aligned and everyone should get the same answer. There is no two answer thing. It is only straightforward and there is only one unique solution. So from the source 1, I got 4.95 angle 180 degrees. So if I convert this into sine, what will be the value? So input is 20 sine 300t. So in terms of t, what it will be? 4.95 angle
And 180.
sine 180 plus 300t, right? 300t plus 180 degrees. Is that clear? How I am getting? Because V angle 0 is V sine 300t. So V angle theta will be V sine 300t plus theta. Is this part clear?
Yeah, please tell one again.
Yes,
So
sir.
we from our phasor thing, if it is V angle 0, which is the input, we have V sine 300t. because input has frequency 300T. Whereas if we have some R angle theta, we'll get R sine 300T plus theta, because that is our convention or the notation that we are following. If 20 sine 300T is 20 angle 0, then 4.95 angle 180 degrees will be 4.95 sine 300T plus 180 degrees. Okay, and this is due to source 1. Now, if I go to source 2, what will be what I need to be considering for source 2? So this is my source 2. So I'll do what with this circuit L? Short circuit or open circuit?
Voltage source short circuit.
Short circuit. So 14 milli, 4 milli. So now we have source 2. So I'll redraw the circuit. 14 milli, 4 milli, impedance, current source. So this is 14 millihenry, 4 millifarad R, and the current source is 2 cos 600T. Okay, so now I will convert this circuit into my phasor form. So what will be the inductance? Same as in the previous case, or will it be different?
Difference.
Okay, and why so?
Different, sir.
Omega is
Because
Omega is
omega
different.
Omega is
changes.
different, yes. So you have to take a note that omega is now 600 radians per second. So j omega L and omega C will change, and tell me the new values. R is R, and this one I'm considering 2, say cos, right? So angle 0 degrees, same. Cos also I'm considering angle 0 degrees, and I'll see according to my convention what I'm getting. Actually, cos should be considered as 90 degrees, but I can still consider 0 degrees. But if you want, we can consider 90 degrees also. It does not matter. So it is just our notation. So have you calculated?
XL is J 8.4.
J 8.4 and C?
Minus J pi by 12.
Okay, I think it will be 0.4167, something like that.
0.4166.
Okay, 416766. Yes. Now, I do not know the value of resistor. So how will I find VC? Say this is voltage due to source 2, so VC2. So how will I proceed? Because they have not given the value of resistor. So what to do?
The total current is given.
Yes. So here we do
So
not need the resistor value because I know this current. So I'll know this current, I'll know this current. If I know this current, I'll know the voltage. So I'll write the equation for VC2. Equation for VC2 is minus J into 0.4167 into IC. And IC is nothing but minus J 0.4167 into IC is what? J 8.4 by J 8.4 minus J 0.4167 into angle, which is 2 angle 0 degrees. Do you agree with this? I have written VCS current IC. So this is IC into the XC, which is minus J 0.4167, which you have calculated. And IC is nothing but impedance of this by summation of these impedances into overall current 2 angle 0. So can you quickly calculate and tell me what you are getting VC? VC2.
Two.
Okay, you just
Point
calculate.
41877.
Okay, angle. We just check, you'll be getting this value, which I have calculated again, 0.876, angle minus 90 degrees.
Yes, sir.
Okay. Yeah, thanks for confirming. So now, I have taken 2 angle 0 as, like 2 cos 600t as 2 angle 0. So now, if I convert this, how it will become in terms of time period t? 0.876 cos 600t
600t
minus 90 degrees.
plus 90.
Minus 90 because we have angle minus 90.
Yes, sir.
Yes. So now, by applying superposition or from the superposition theorem, we know that, so if individually it is VC1, VC2, then overall we will get VC
VC1
is
plus VC2.
VC1 plus VC2. So first let me write the overall expression, or you can tell me so that I'll write. So my VC is what? Earlier we got 4.95 sine how much? 300, 600,
300t plus 180.
180. And the VC2
0.876 cos 600t minus 90.
Okay. So now this is the equation. Okay. So now let us quickly go back here and whatever they have asked, I am just clipping so that we can correlate directly. Okay. So now can you tell me what is theta, what is A, what is B, what is phi?
A equal to 4.95,
Hmm.
A equal to 4.95, B equal to 0.876.
Okay. And theta
Theta
phi?
equal to 180 degree, phi equal to minus 90 degree.
Everyone agree with this? Hello.
Yes.
Okay. But there is a catch here. One thing you need to check is what term they are asking. Or better, I should use a different
Cos.
color. Yes. So they have asked.
A into cos.
So we got sine. They gave cos. Here we got cos. They gave sine. So first we need to formulate this in cos and sine. So can you tell me now what will be the expression 4.95 sine to cos? So sine 300t plus 180 degrees will be cos what? 300t plus
180 plus theta.
You use this sine 90 plus theta is equal to cos theta. Now tell me what is theta. Ninety degrees, right? Sine 90 plus 300t plus 90. So it will be cos 300t plus 90. Understood how I am writing?
Mhm.
So this will be 90 degrees. So I'll use a different color. So now cos theta I have to convert into sine theta. So how will I do? So first I'll
Cos
use
90
this.
minus theta.
So cos theta is equal to cos minus theta. Okay, from there I will be getting cos 600t minus 90 degrees is equal to cos 90 minus 600t, right? So what is cos 90 minus 600t? Sin 600t, right? because cos 90 minus theta is sin theta. Agree?
Yes, sir.
Yes. So now this will be 0.876. Sin theta is sin 600t. Sin 600t plus 0 degrees. So this is our actual format in the way they have asked. So now if I calculate the answers, I will get A is what? 4.95, right? Do you agree? A equal to 4.95.
Yes,
And
sir.
B is 0.876. Okay, first we will check A and B. So A is how much we are getting? 4.95. So it is in the range. And B is how much? 0.876. So it is also in the range. So theta, they are asking, you have
90
to see.
degrees.
Theta, they said it is in radian. So you have to convert it to again radian. Theta is not just 90 degrees. You have to convert it to radian. So there are so many ways
Pi
that
by
we can make a mistake in this question. So we have to be very, very careful. So can you tell me what is theta and what is phi? So this is AB. And now theta is how much?
pi by 2.
Okay,
Pi
so
by
in
2.
radians.
And pi is 0 degrees. 0 radians.
Yes, so phi is 0 radians. Theta is in radians how much? Pi by 2 value?
1.57.
Yes. So 1.57. Let us just go back and check. Theta is 1.57 lying in the range. This is also 0 lying in the range. So is this question clear? It's a bit tricky question, but very straightforward. So let us go back and okay, so it is taking time. Okay. We are given this kind of circuit with two sources. They are asking VC. So we have applied superposition theorem so that we can individually solve. Voltage source is shorted, current source is open. First current source open. Then we got x1 by x1 plus x2 into V input, and then we got VC1t straightforward. VC2t resistor is not needed because we know the current entering these two by applying KCL and then calculating the currents as well as current multiplied by impedance is the voltage, you will get the voltage. Now the addition of these two will be the voltage because that is what superposition theorem says. But there is a catch because they are asking in cosine term and sine term. We got sine and cosine. So by using basic trigonometric math equations, we have converted this into cosine and sine in the way they have asked. Still theta they are asking in radians. So 90 degrees is pi by 2 radians and phi is angle 0 degrees. So until this point, is this clear?
Yes, sir.
So this question I will not get time, but I will tell you how to solve and probably I will give you answer. So you can go to my video and check if you are getting the same results, answers or not. So this is our problem 3. You can see my screen, right? So this is my problem 3. So how to proceed? They are asking I1 angle theta, I2 angle theta, I3 angle theta 3. So how to proceed? Any ideas or any thoughts? Okay, so which way of solving would be good? KCL, KVL, or
The KCL.
yes. So this is my 0, right? So this voltage is 50 angle 120 degrees. This is 50 angle minus 120 degrees. This is 50 angle 0 degrees. Because they have given ground, so minus plus, minus plus, minus plus. And I'll quickly solve because we are running out of time. So this assume V. Now I apply KVL here. Sorry, KCL here. So summation of all the currents should be 0. So I'll be getting in what format? So apply KCL. So first you have to solve for 50 angle 120. 50 angle 120 degrees minus V by 50 ohm plus 50 ohm plus 50 angle minus 120 degrees minus V by minus J50 plus 50 angle 0 minus V by J50 is equal to 0. Okay, now we have one equation, one unknown. I will not solve it here, but you just solve it later. But as this video will be uploaded, you can come here and always check. It will be 36.6 angle minus 60 degrees volt. So this is my V. So first I have solved for this node voltage V because I need to know the current. So I need to know the potential difference. So I need to know the voltage at two different potentials. I know at this potential, I do not know at this potential. So I have applied KCL and then I got one equation. Solving that, I got V. Now this is my I1, right? So now what happens? This is my I1 and this is my I2 angle theta 2. Say this is I1 angle theta 1 and this is my I3 angle theta 3. Do you agree?
Yes, sir.
Okay. So I will just write the answer whatever I got, but you later check. So this will be 1.732 angle 120 degree ampere and this one will be 0.896 angle 75 degree ampere and this will be 0.896 minus angle 45 degree ampere. So I'm just giving an idea of how to solve this. It is a straightforward question, but the question we have solved at the end, that is a bit tricky. But this is also a good question. But as we did not have enough time, we could not solve this. But I gave you an idea. So let me just revise what we have discussed in the problem solving session. So in the problem solving session, the first question is an RLC network and they are giving voltage. So they are asking currents here. First, we found out the reactance, complex reactance, and this XL, this XC, these resistors are given, and this L and C are given. We have calculated XL, we have calculated XC, then we found out that impedance is infinite, and then we have proceeded and calculated the current. Then we found out the voltage. Then for calculating current, V by impedance is the current. So we have calculated IL angle theta L, IC angle theta C, IR angle theta L. Then they have asked reactive power, which is VI cos theta. Theta is the angle difference between VI, not the angle of V, not the angle of I. It is the angle difference between V and I. So applying that, we got it is a pure resistor. So active power is there, reactive power is not there. In problem 2, it is a superposition. We have applied superposition and calculated the capacitor voltage in the case 1 as well as capacitor voltage in the case 2. And then we have done some basic mathematical manipulation and we got the values. In the problem 3, it is a KCL question. So you apply KCL by assuming this voltage to be V. One equation, one unknown, solve for V. And these individual terms will give I1 angle theta 1, I2 angle theta 2, I3 angle theta 3. So yeah, that's how we have solved. And yeah, probably your assignment question also will be quite similar, but this is the way of solving. I'm just giving you an idea. So if you have any questions, you may ask, else we can wind up this session. We are close to 8 p.m. I hope these sessions are helpful to you and you are learning and you are having a better understanding of this session.
Yes,
Of
sir.
the concepts.
Yes, sir.
Okay. So if you have no more query, then we can stop here. The time is also out.
Yes, sir. Yes, sir. We can stop here.
Okay. Okay, then. Thank you. See you in the next week. Good night. All the best
Thank
for
you.
your
Thank you, sir.
assignment. Bye.